going to make a kind of hard shift of gears from talking about English and how to symbolize it to talking about how we describe our logical system. So this goes from using the logical system to talking about it. And the distinction between using language and mentioning it is going to be an important one to understand to express how it is we manage to talk about our logical language. So in general, sometimes we don't just want to use language to talk about the world, we want to talk about our language. So when we say Mercury is a planet, we describe the world. When we say Mercury, in quotes, is the name of a planet, we describe the word. The first sentence uses the word Mercury to talk about the thing the word refers to. It's talking about the planet. The second sentence mentions the word Mercury in order to talk about the word Mercury itself. So this is the distinction between use and mention. Commonly, we use single quotation marks around words to signal that we're going to talk about the words themselves. So quotation is a common device for talking about language rather than using it to describe the world. So if a word is in these single quotes, it's being mentioned. And then it's not the same as the word in quotes. So contrast the two sentences below. They sound the same when you read them out loud, but they mean vastly different things. Mercury is the planet closest to the sun. That's a true statement. Quote, Mercury is the planet closest to the sun. That sentence is absurd. It says that a word is a planet. So when a word is being mentioned, it doesn't have its normal meaning. It just refers to the thing in language and not the thing we use the language to talk about. The use-mention distinction is relevant to how we study logic. We use symbols of truth functional logic to formalize English sentences. But when I try to tell you about truth functional logic and its sentences and its symbols, I'm mentioning them. So here's an example sentence where sentences of truth functional logic are being mentioned but not used. If H then not S is equivalent to if S then not H. There, those statements of truth functional logic with our connectives and simple statement letters are being mentioned, not used. In this case, truth functional logic is what's called the object language. It's the one we're talking about, the one we're trying to describe. And then we use an English phrase, like is equivalent to, as what's called metalanguage, a language we use to talk about the object language. So the idea is that English isn't a part of truth functional logic. We can't use English in our set of symbols. But we have to use English to talk about truth functional logic. This might make more sense once you recognize that you've already seen part of the metalanguage for truth functional logic. The metalinguistic variables like these curly A's and B's that you saw in the rules for sentences are part of the metalanguage. Right? They're not symbols of the logic that we can use to symbolize English sentences. Instead, they stand for expressions of TFL. So they can be replaced with any sentence of TFL where we mention it instead of using it. Remember too that when you looked at those rules that contain the metalinguistic variables, only part of the rules were variables. The rest was in English, plus some technical additions. So that is a reminder that English is our metalanguage for talking about our object language, truth functional logic. We've used metalanguage so far to describe the sentences of TFL, but coming up, we're going to want to talk not just about sentences, but about arguments in our logical language. So with that in mind, we're going to introduce a new symbol to our metalanguage, and that is this triple dot. So this symbol is part of the metalanguage, and it's used to signal that a sentence is the conclusion of an argument. So here we see a string of the metalanguage, curly A1, dot, 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 curly AN, therefore, that's how we would pronounce that symbol, C. That's a sentence of the metalanguage that characterizes how an argument is organized. A series of premises, A1 through AN, supports, shown by the 3 dots, a conclusion, given by the curly C. Since A1 through AN and C are metalinguistic variables, we can substitute sentences in them to generate an instance of a particular argument. So I could do A or B for A1 and not B for A2, and then therefore A as an argument. That wraps up lesson 2. By now, you should have a good grasp of how to symbolize English sentences, including ambiguous ones, into truth-functional logic, using sentence letters and our 5 logical connectives: negation, conjunction, disjunction, the conditional, and biconditional. You should also be able to determine whether a set of symbols from truth-functional logic is a sentence. You should be able to determine the scope of a connective. And then going forward, you should be prepared to use this distinction between the metalanguage and the object language to understand what we do when we go to evaluate arguments.